Hello and welcome back to Jules Bench. My name is Greg Perugini and this lab is on lens parameters. So let's get to it. Now the majority of telescopes are either going to be reflector or refractor telescopes using lenses or using mirrors. We're going to do our experiment here, figuring out the lens parameters using the lens that is in your kit as well as this laser pointer. Now a reflector telescope uses mirrors and a refractor uses lenses. The first telescope was a refractor. First telescope used to look at the heavens was by Galileo in 1609 to view Venus, the moons of Jupiter, and the moon itself. So how a lens works is that light coming in, parallel incident rays, because of the curved nature of the lens, will focus the light to a particular point. We'll call it the focal point. That point is a characteristic of the lens. If I were to have my eye here or here, I would not have a focus. It would not be focused. So this distance here is important. We'll get to that in a minute. But this distance is the characteristic of the lens. So this could get pretty complex here. If you have your eye, you can see how a telescope would work. Light coming in, we can see this image because this is going to focus down to this point, and this lens focuses to that point, so we would be able to see the image. If they were not focused at the proper point, we would get a blurry image. And in fact, if you don't have a proper focal point with your eye, you would not have a focus on your retina, and you would need a glass here, glasses, or you would need LASIK surgery to correct this. So, how do we do this? We have this biconvex lens, and it's got a pretty long focal range. So, if I am going to shoot this here, and I'm shooting here, if I shoot in the middle, it's going to shoot directly a straight line down my grid paper. But if I move it towards the camera, it moves slightly in the other direction. If I move it towards me, it moves slightly in the other direction. So you want to try to, either you have this on a stand or whatever, or you can stand it like I just did, and draw lines to the points as you see here. So you're going to put it at one edge, and it's going to come down this way. First you're going to put it where it goes to focus down the middle and draw that line. Move it off to one side, draw that line. Move it off to the other side and draw that line. And they should all intersect at a given point. For your lens, depending on the lens, it could be anywhere from 120 millimeters to 150 or 160, 170 millimeters. The focal length is this distance between the center of the lens and that focal point. So that's what you need to come up with. That's this lab's result. What is the focal length of this lens? Measure it as accurately as you can. Take your time and complete the lab material as per your instructor. And good luck.